So Allison, here is the problem you sent me this morning. You're given the function g of x equals e to the x to the third minus 6x squared plus 8. Since this is an e to the u function, the derivative there, the formula there is e to the u times the derivative of u. The derivative of just e to the x is just e to the x. But if it's anything, if that exponent is anything other than x, then we call that exponent u. And so then the derivative becomes e to the u. So in this case, e to the u would be e to the x to the third minus 6x squared plus 8 times the derivative of u. And in this case, the derivative would be 3x squared minus 12x. And you were asked to find when this original function g has a negative, is, I think, decreasing. And so that's going to mean that you're going to have to find where the slope is negative. So that's why I wanted to take the derivative there, so that we could calculate where the slope is negative. Now, one of the things you want to realize about this is that you have, a product. So you've got, you could think of it as the 3x squared minus 12x, that's your a, and the e to the u, that's your b, right? And if either of those, if one is negative and the other is positive, it'll come out negative, right? Well, the thing about the e to the u piece, that is always going to be positive because e is positive, and even if the exponent were to come out negative based on the value of x, e to a negative exponent is still going to give you a positive number. For instance, e to the negative third is just 1 over e to the positive third. So it's a small number, but it's not negative, and it never will be. So the only way we're going to get a decreasing function is to have a negative slope, and for a, that piece of the derivative, the 3x squared minus 12x, would have to be negative. So what I'm going to do is I'm going to find the zeros of that function. So I'm going to say 3x squared minus 12x. I'm going to let that equal 0, and I'm going to find the zeros. I'm going to factor out, this is a binomial, so I'm going to factor out the GCF of 3x, and then I'm going to have an x minus 4 left in the parentheses, and that equals 0. Well, when will that equal 0? Well, that'll equal 0 if 3x equals 0, or if x minus 4 equals 0. And that means x would have to be 0, or x would have to be 4. So in either of those cases, you're going to get 0 as your output. So what we want to do then is, if we know that those are the x-intercepts, then if we can find what's happening between those values, then we can comment on whether the slope there is positive or negative. Now remember, this is the slope. So at x equals 0 or at x equals 4, the slope is going to be 0. So the question is it ever negative? And I'm going to make a sign chart. I don't know for sure that your teacher does this, but you draw just basically sort of a number line, and then you mark off your zeros. So we have a 0 at 0, we have a 0 at 4. And the question is, what happens if x is less than 0? What happens if x is between 0 and 4? And what happens if x is greater than 4? Because we know it's not 0. The only two zeros are at 0 and 4. So we're going to plug in, we're just going to pick any number, like x less than 0. An easy way to check that would be to just put -1 in. So if I take my expression that I've already factored, and I just take 3x, so 3 times, we're going to try -1, because that would be in the interval where x is less than 0. And we're going to multiply that by -1 minus 4. Well, 3 times -1 is -3, and -1 minus 4 more is -5, and a negative times a negative there is going to give me a positive 15. So in this interval, the slope is positive, so the function would be increasing. Now on the next interval, 0 to 4, we could choose like 1. 1 is between 0 and 4, so I could say, okay, 3 times 1 times 1 minus 4. 3 times 1 is 3. 1 minus 4 is -3. That's going to give me -9. So there's a place where the slope is negative, so the function would be decreasing. And then we need to check out this last interval where x is greater than 4, so we could put 5 in. So we would have 3 times 5, and then we're going to multiply that by 5 minus 4. And we're going to get 15 times 1, also known as 15, which is indeed positive. So we can see from this that there is only one interval in which the function, the original function, is decreasing, because that's where the slope is negative, and that is on the interval from 0 to 4. And I believe there was a choice, I don't remember which one it was, I think it was B or C, was from 0 to 4 was the interval. So that would be the choice I would make there. I hope this helps. Let me know if you have any questions.